Hello, if you have anyone watching. We're still having some technical difficulties here, so. Actually, I'm going to switch to Safari since I find it works a little bit better here. Hello, hello. Okay, Jearvon says 1 second. So hopefully we'll have the on-site Philly.rb room back shortly. Hello. You're back, but muted. Zero viewers. I think we had 1 viewer there for a second. Got to work on these ratings. You're muted there, by the way, Jearvon. Maybe I can unmute you. No, I can't unmute you. You need to unmute yourself. Oh, I can unmute you. Neat.
All right, I switched to my work computer.
Oh, yeah. It gave me a chance to. Yep. Yeah, you sound good.
I can't hear you.
Oh, maybe your speakers or something. I see little green dots, so I think things are good on this end.
Now there's no sound.
Yeah, sure. It's a shame. If it was the opposite, we'd be good to go. But if I can't talk, that's going to be a problem.
Can you say something?
Hello, hello, talking now. Check. Yep.
No. Can you say something, Matt?
Test. Audio. I thought I heard someone say there it is. Check. Sound output. Testing. 1, 2, 3.
Could you say something now?
Testing. I'll just keep singing a song or something. Yep, I am talking. It'd be really fun for people to watch on YouTube. A recording of me just talking to myself, making noise. Not having any luck. I'm trying
Can you say something
to
now?
talk continuously. And
No.
probably
I think it's because we're airplane.
Really silly.
Okay.
Recording.
So AirPlay default.
AirPlay.
But now.
Hey, hello.
Yeah. All right. 1 second. Can you try again?
I'm talking now. Can you hear me? This was working a second ago. Whoa.
Yeah. All right.
I heard my own voice there. That's a good sign.
This thing is not working.
That's okay.
So we're gonna just do this.
Yep.
Is that okay?
Yeah, that'll be fine. Doesn't have to be perfect, just to get a feel for
All right.
who's all there and if people are watching. Alan, holy cow.
That is true. Cool.
I haven't even seen this office yet.
All right. So I can hear you, but you sounded very. I guess people are talking also.
I can move the mic a little bit closer too.
So maybe. All right. Yeah, we'll turn the AC off.
Yeah.
And also, when people are more quiet, it'll be fine.
Okay. Yeah, I can. I
also
might.
get up the
Hopefully, I'm not.
the speakers.
Yeah. I might be maxing the mic out a little bit.
Okay.
Let me. Is that any less practical?
Actually have the same mic as me.
Oh, is it the same one?
Yeah, that's better.
This is a great little microphone, isn't it?
That was good.
Yeah.
Yeah.
If I run it on -10 like this, I have to keep my mouth pretty close to it, but at least it shouldn't crackle.
Yeah, that's when I can recognize what you're saying.
Yeah. Cool. So sounds okay now. Do we have video?
Yeah, I think that sounds okay.
How about the video feed? Do we have anything going for that?
I'm gonna get some food and maybe see. Do you need anything else?
I think I'm good. What about? Am I already broadcasting to the AirPlay right now?
Yeah. So you're on the TV.
Okay. Cool.
So I'll just full screen you.
Yeah. I was just. I'm gonna start the slide screen share. Can you see that all right?
I can see your screen.
Yeah.
Your slides. Well, I see a white slide.
Yeah, it's just a white slide for now.
Okay.
Present to everyone. Cool.
Yeah, you're just live right now.
Yep. Can you you can hear me all right?
And it's recording?
Yep. And we're going on YouTube as well. So you'll get to hear me singing for a while you sorted out the audio.
All right.
Cool. Go get some pizza.
All right, I'm gonna get
and
some
we're ready to start.
Quick. Let me know if you need anything.
I'm good. Give me a pizza. That'll be good. Just shove it through the camera.
Well, the plus side of that big working day is plus side not working as a mic. So I guess I can just You want to go to the bar after that? It's probably like 8. One second. So, what's your slide?
I mean, probably kind of the next it's like they require. I mean,
Yeah, are you there?
yeah.
Hello? Talking to me?
We're gonna start now.
Fantastic.
Yeah. I'll go through announcements and stuff,
Cool.
and
Excellent.
then I can talk. Hello. Welcome to the May. Whoa. The May meeting.
Hey, everyone.
Say hi to Matt. Hi, Matt.
Hey, everyone. Thanks for bearing with me with this presentation experiment.
So Matt used to organize Philly.rb a while ago. Idea to move to a faraway land. So yeah, and he wants to give a talk. So sure. So this is the May meeting. This year hasn't been great with meetings. We are looking for speakers for the rest of the year. Conflicts with the room at Comcast. You know, some people don't book them on time and stuff. Just kidding. But hopefully, we will be on track to have more meetings and more activities. There's another meetup night. That's, I think, Alex. You can talk about that a little bit more later. They meet, I think, once like every first Tuesday.
On June 7th.
Okay.
Yeah, you should. Yeah, that's
Okay. Cool. And that's just a night where if you're a junior developer or a new developer, you can go hang out and work on something. And they provide different talks, different activities. Details are in the meetup. I guess housekeeping. This is the Wi-Fi. Guests, and the password is handcrafted. They make handcrafted software. I just like to poke them every time I say that. The bathroom, by the door, there are Ethernet keys. The white is for the female bathroom, which is right outside the door, and the red is for the male, which is you keep walking and there's a fire hydrant thing close to the ceiling. It's the next door. We have two sponsors tonight, PromptWorks. I used to work here, great company. I'm sure they're hiring. They do Rails, Python, what else, Dave? A bunch of stuff. It's a great company. Another company that's sponsoring food, Agile hires. Did I get it right? Yeah. All right, cool. That's round of applause for Agile hires. Just going to say about the company and what they're trying to do.
So thanks for having me, guys. Be up here real quick. So my name's Eric. Again, started my company hires 4 years in July. My background is I went to school at Drexel for information systems. Started off in comp sci, worked in tech for like 10 years. During that 10 years, I dealt with recruiters all of the time. 0.5% of the interactions with recruiters was terrible. I really did not like interacting with recruiters. It typically seemed like they had no real understanding of what a career path looked like. It was basically a numbers game, right? Let's find as many candidates or as many resumes with as many keywords as possible, and then send those as many places as possible, and hopefully they'll stick, right? What I found out later too, which is kind of my thought process then, was most recruiters aren't even recruiters on purpose. Most recruiters are recruiters by accident. It's not the first career choice. They just found out, I talk to people, and I'm completely sensitive, and I can type a little bit, you know what I mean? So they became recruiters, and they get these grandiose ideas of, I want to make $200K and go to Vegas, and watch every night. My job is, but it's really just kind of it's very spammy. It's very a whole bunch of stuff against the wall and see what sticks. So I was like, this is just bad. I don't like it. It seemed dumb. So I started. I changed careers, worked for somebody else. All my fears were realized. I was like, this is exactly what I thought I was. I figured I'd learn all I can learn from these Jearvons in about 2 years. And that's why I started at Hires. And pretty much the goal was just to give everybody the experience that I wish that I had to recruit. So work with a ton of startups in the city, or a ton of like small, medium-sized companies. The companies tend to be smaller if I can really get to know the people who run the companies, and so I can understand their vision, who they're looking for, and what they're building, and try to help them realize their potential. So yeah, Untitled Hires is super busy right now. A bunch of jobs open. I have like 2 or 3 Ruby jobs open, and a bunch of fun developer roles. Transitioning out of doing this and into launching my own startup that will hopefully put this business out of business, and hopefully 90% of all the other recruiters, pretty much any recruiter that's not internal. It's called Skill Hire. I found a team that's really for me, and it's basically doing job matching based on several criteria, including an actual skills test, so you can do the job. So there will be no more. The idea is there will be no more discrimination based on your resume. The job, you will get an interview. There's no profile pictures. People can say, "Oh, they're too old. They're too, I can't pronounce their name. I don't recognize that school they went to." None of that kind of stuff is going to deter you from getting, an opportunity to interview for the role. So that's what I'm building now. But concurrently, I'm running Untitled Hires. So if you guys are actively looking, if you know somebody who's looking, I'd love to write people checks for referrals. I just wrote my buddy a check for $500. Somebody else another check. Yeah, feel free to hit me up afterwards. I've got business cards, this and that. And I'm also the project that I'm working on is being built on Rails. So I would love to get more feedback, or if you guys want more features in the future, or also I would love to get this as it comes out in beta form. I'd love to get in everybody's hands so I can test it out and then get feedback on that. Or even just give it to the companies that you work for and be like, hey, this is a new solution. Never have to post a job description again. Never have to work with the recruiter again. Those kind of things. So yeah, if you have any questions, feel free to talk me afterwards.
Thank you. All right, announcements. I don't really have any announcements. Do you all have any announcements? Like community stuff that's happening at conferences, like coming up. Strange Loop is coming up. You should try and get a ticket to that. It's a great conference in St. Louis. There's one in Pittsburgh called Abstractions. There's $250 with a really good speaker lineup. Pittsburgh's pretty cheap and pretty close. Abstractions.io. Anything else? Anything?
Yeah. Twilio Signal is coming up. Twilio.com/Signal, South San Francisco. 24th, 25th, Dave here is speaking there. So my promise, some of you want to come out there. Talk to me if that's interesting to you. May 24th, 25th, San Francisco. I got a promo code for fun.
Cool. Do you have any announcements, Matt? Anything happening in your side of town? No. Do you have any announcements, Matt?
No, I think I'm good.
Okay. So we're gonna have 2 lightning talks tonight. One by Alan, and one by me. And then we're gonna do the main talk. So hopefully this goes off without any problems. All right, man. I'm gonna disconnect you now.
Sounds good.
From AirPlay.
Yeah, fair enough.
All right, Alan, you ready?
Yeah. Okay.
So I think if you just turn it on, and I'm not gonna turn it off. Don't worry.
It's like
Oh, that's your house.
Yeah, that's my house.
You see Matt?
I sure can. I don't know if you can hear me. It's good to see you, Alan. It's been too long.
Yeah, hi, Matt. Actually, you're responsible for this,
Oh,
believe it. Because your last meeting 3 years ago here when you announced you were heading off to Netflix,
I did a lightning talk on email address validation, and
So that's the trick. I need to talk to get Alan to talk. All right.
and at the end of the talk, you said to me, "You should write a gem."
And there it is.
It's been not quite 3 years to make, but the idea has kind of evolved a bit over time. So it mostly just finished up earlier this year. That have something that I think is interesting. Now, most email address gems and things we talk about really just do validation. They just take a string and say, "Hey, is this a valid email address?" Usually through some voodoo regular expression or something. And I wanted to, I started with that, but then kind of realized there was a lot more to it because my day job is working with email lists and email addresses, tons of them, and making sure they're all valid. So, and have a lot of issues that come up and a lot of interesting problems that I also wanted to kind of explore here. So some of the parts of the email address gem really handles is identity, making sure that this is an email address that matches a particular person, your email account specifically. It could be a role account, it could be a mailing list. But in today's internet, it becomes almost your social security number for a lot of web services and things. Certainly validation. If you just wanted validation, this probably isn't. This gem may be a bit overkill, unless you really wanted the down dirty the level validations that it does. Comparability. I can also compare two seemingly disparate email addresses and seeing if they're actually. Which means that you could introspect within the email address and say, is this a Gmail address, or is this an address that AOL handles, or is this an address that goes to an MX server with these IP address you can do it by CIDR blocks. If you don't know what CIDR block is, it's just a way of blocking off a number of significant bits of an IP address. So you can say, something that began, with the first 24 bits significant, so anything in that last dotted quad works. Provider-specific rules are pretty important here. I have coded just, some of the major players in the field, but everyone has their own different rules. Like Gmail specifically, they have optional dots in their email addresses. You may not realize this, you might. But if you do like first name dot last name with your standard canonical email address, you can just say first name, last name. You can say put a dot between every character. You can put 2 dots in a row, which is not actually a valid email address, but it works. There are other things I'm using, just trying to identify how to make an email address canonical to, so that you can help identity. And I also threw in a couple Rails helpers in there, just for kids. So the crux of my last lightning talk a few years ago was don't RFC validate email addresses, it sounds like a crazy concept, but when you really look at it, email addresses, the specification for are really part of what the MIME headers of email. They're all parts of these dotted quad word tokens, and they don't really have any meaning to a particular email system or identity, to email addresses and users and such. The specification says they're case insensitive, so case matters, that's not very good. That allows spaces in them and special characters. You have to do quoting and escaping, which causes a lot of confusion. Most of the stuff is just going to be probably incorrectly entered anyway. So even if it is valid, it's probably just gibberish. You got hosts, that thing after the @ sign, can be IP addresses, IPv4 or 6. You can have comments, which are part of the email address, which are just, they're usually back in the old days just for compatibility, because you didn't really necessarily have address books, and so you can put names associated. Newer RFCs use SMTP UTF-8, which allows you for systems to accept UTF-8 as local addresses. This is still very nascent, and realistically, most of the world does not run on UTF-8, so I don't think this is really prime time thing. So here are just a few examples of some valid email addresses. First is case sensitive. Second is as an IP address. The third is just, those are the characters. And fourth is the comment, which is a parenthesized comment, which can be on either side of the mailbox and also on the either side of the domain name. Final line is a UTF-8 string, just format. I threw something Japanese in here. I don't know specifically what it is, but
Anything to say about his mom, but
it's mother-in-law. All right. So traditionally, validation of email addresses were by voodoo regular expressions, or you use libraries. But really, the only real way to know is by sending email to, and seeing if it comes back. You're never really sure if it was properly. It may have been received, but filtered off, or mailbox was full or something. It's kind of hard. So if you're trying to go through a registration process, you really want to eliminate the chance of someone just giving up, from the get-go. My gem does parsing by breaking down the constituent parts of the email address and the domain and validating each one independently. And as I said, I have email service provider or internet service provider specific rules for their lengths and special user characters. Okay, but to do this, I had to create kind of a new forms of email addresses just to identify them in my head. Standard email addresses are whatever's standard compliant. Then I realized conventional email addresses is what I'm talking about. Things that everyday email address users, user email addresses. And then you can also add tags into email addresses. With Gmail lets you do this with a plus sign. Some other services do. Excuse me. Sorry, some other services do too. This adds, it's pretty much like doesn't actually it creates a new address, but also it just allows for easy filtering at the user end. And the canonical email address, which I want to identify as unique as I can to a specific email account. So in this case, I have first dot last plus tag at international domain name. And really, we realized that if this was like a Google Apps hosted Gmail type account, that the period is irrelevant. So we take that out. We drop everything to lowercase. We take
Wah, wah. Technical difficulties. Well, I'll hang out here until Alan gets back.
domain names, and there's some special nomenclature here, what the domain name or the provider or the top level domain or a glob of the domain name. Gmail dot is what I call the registration name. It's everything. It's the token above the top level domain and logs by user.
Oh, not you. Sorry.
I thought you were trying to get rid of me.
Yeah.
Also, I have a couple Rails helpers in here. You can use the Rails 5 attributes API with this to create to create automatic assignment. Magic happens. So in this example, I also have a validates with email address validator, standard thing that you get anywhere else. But it uses my validation, and you can set up a setter for email to set the canonical email address and the email address, and all that's happening within the libraries through the attributes API. And that's all I got. You want to have any questions? Well,
So first of all, this is awesome.
thank you.
So thank you. Secondly, how are you doing the parsing on the other?
Mostly, I'm not doing RFC level scraping. It is a good expression, but so I can understand it.
You consider using something like parsing it?
It seemed like overkill to me during the time. It might eventually make sense to do that. It's just I know regular expression pretty well, so there we go.
Awesome.
Yeah, it's.
I've had to do this before where I ended up doing a head request to the mail server itself and asking, is this a real account?
Yeah,
And
I don't like that.
yeah, I know. It takes you out of time. It does a lot of, introduces a lot of dependencies, and that server could just be napping.
Yeah.
So you could get a lot of false negatives.
Exactly.
But
and you have to be careful how you're doing this, because if you're doing it off your own IP address, you have to make sure that your reputation on that IP address is fine.
right. Yeah.
That if you do too much, it looks like a dictionary attack. You can start getting booted at.
Yeah.
My test suite, on my work app does some things like this, and I have to be careful. I can't run it from my home IP. It doesn't work on some of that when I want it to go out. But I have to make sure I have it on a public IP, not the home IP.
Right.
There's also third-party services that you can use that you can just say, hey, do this for me, and they'll cache results from different people and sell you for like a penny or something. All right, thank you very much, and thank you, Matt.
Nice work, Alan.
All right. I'm going to give my lightning talk now. Now, I'm going to share my screen. Wrong thing. All right. All right, so how many people use CI here? Something that runs your test suite automatically. Do you use? You shout out.
Jenkins.
Jenkins.
Travis.
Who's that? Travis. Do you pay for it? Okay, it's just open source stuff. Does your company pay for it? So Jenkins, Travis. What else? I feel
Circle CI.
sorry for you. At Comcast, and we have a bunch of different. Imagine Mike and I are in the CI task force. We just want to use better tools, be a better company. This year we tried out Travis. I don't know where Mike has landed with Travis. Travis is great. I use it for open source. We were using the enterprise solution, so that was a downside to look at stuff. I had to go through Mike for it, and I've had drone in my head for some time. So I'm not going to show you like our instance of drone, but maybe some of the Travis. There's an open source, and you can pay for it, and it's free. So it's all in Docker. Just Docker run. It can run on SQLite. We run Postgres. We do not run it in any container service. We just have a Docker instance running, a super large EC2 instance. So the plus side of something like Drone or Travis, and I know like some work has been done on Jenkins to do in the application file, and that does everything for you. So your CI run lives in repo. So this is Drone's YAML file, and I just learned something that they have a pipeline tag. So I'll have to look that up. But the cool thing about Drone is it uses Docker Compose or something similar to it under the hood. So if you need a Redis or a Couchbase or something else, you just specify that container and it automatically does the auto linking for you. So you just compose whatever your infrastructure looks like. They have these events, so conditions on your bills. So this is a bill that they're doing. Golang. And they're doing a bunch of shell commands. You know, they have a makefile that does some stuff. It's going to run it. This event is only going to happen when it's a git push. A bunch of events, whatever events that. So we use GitHub Enterprise. That GitLab integrations, whatever other stuff. Out of the box, they cover all these languages. All you hipster languages experts, there's something for you here. Even if it's not here, you could use whatever is on Docker Hub. I think you can also use your own Docker registry. So we're about to embark on that. That is Docker container. You can end up shipping a Docker container. Online tool called Drone Exec executes whatever is happening on your CI. So if working, you run Drone Exec, given the repo, and it'll run that, spin up a Docker container locally. So you need to have Docker machine or boot to Docker, whichever one is a popular one today, and you can inspect it. Thing is secrets. Similar to Travis, it handles secrets a little differently. Encrypt files or environment variables. Drone a YAML file. Query around. Run your own, like encrypt a file with a secret YAML. Change the way you do secrets. So I guess did that confuse y'all? Questions about that? Mike, do I need to explain something more? Mike is my inner chief. He tells me when I need to explain something more in depth. Questions? I think I was really more prepared when I gave this earlier.
Can I ask a question?
Speak to what it requires to operate.
So they used to distribute a Debian package. They have since retracted that. Docker image. Run, pull the image down. Fix. The docs are really good. docs. On this page, we have a link to docs that are very helpful. So the host it yourself is a complete rewrite of drone, so it's going to look different. Don't let that worry you. Before, everything was click, 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 and now they're going to more of a containerized your configuration in the repo itself. Guide.
Am I coming through? Can I ask you a question?
So basically, sudo docker pull drone, and every drone release is a tag. So if you want the latest, do latest. Let me show you what I did. Yeah, so basic thing, boot up something with, if say DigitalOcean, they already have pre-built boxes with Docker, and you just copy this, and then you paste it, shell, and you have drone running. And it has a dash restart, so if your drone dies, it's going to automatically restart your instance. Cool thing is, like with Jenkins and stuff, you have build agents, so they're dirty. With Docker, every time it's a lightweight container, so it's not, it doesn't slow you down, it's super fast. Container super lightweight. Another cool thing is using some. So I guess this is what they support. It's written in Go. Go is very hard to debug, but it's an easy language to pick up. And I'll end. Store. So let's say you have a gem, internal gem. When you tag it, it'll do a release to GitHub releases or to internal gem server or to Ruby gems. Yeah, there's a Slack gem, Docker Hub, whatever you please, you can do with it. Integration. And all this stuff is on GitHub. So if you're having a problem, you can look at the code or you can clone it down, run an example with your thing is, and see the output. This is pretty cool. I'm waiting to try to use this. A Terraform build finishes. You can use Terraform to get around it. Any questions? I think the AC is about to come back on. Okay. Are you impressed at least? Yes. It's free, and it's written in Go.
The one thing you showed.
It's free. So if you host it yourself,
okay,
on-prem or on some box somewhere, they're super helpful. So there's this thing called Gitter, which is like Slack, but for open source projects. And they'll answer your questions. I've asked questions at like 1 o'clock in the morning. Can't sleep. And they replied, which I don't know if you want to use code when people are committing at 1 o'clock in the morning, but they're in a different time zone actually. It's still 11 though.
But is it easy to set up and get running?
Yeah, so all you do, Docker run, and that's it.
And then you have to set up your own.
What do you mean? Log in with GitHub or whatever.
Okay.
You click accept. Yeah, then it'll boot up the interface on port 8080 or whatever. It'll show you all the repositories that you have access to. Click activate, and you're done. I can show you what I did to set it up. The Terraform file that we used to set it up. Basically, I set up RDS, which is AWS's database as a service, some security groups. That's all it takes. It's reproducible.
And where did you install the host dependencies?
So I have this file, which the only dependency is Docker with a provisioner, a Terraform provisioner. You want to see the just the inline script that renders out. I can add utility code later.
You said Docker itself is running in a container, but other containers to run your stuff inside of that.
Yeah, everything is a container. Yeah, it has a bunch of. It talks to the main daemon.
Usually there's some kind of persistent data store backing.
I'm using Postgres. May default to SQLite, but you do not want to do that. I was getting lots of corrupted stuff. So yeah, unless there are any questions, you can talk a bit about it after. But yeah. All right, Matt.
Can you hear me?
Screen. Uh-oh.
Time machine.
Is there
Can
way
you hear me
can
on
boot
that
me
end
from
or
sharing
no?
screen? I can hear you.
Okay, good. All right. I was trying to throw a question in there. I don't know.
Really low. What was your question?
Oh yeah, I was just curious. Does Drone have anything in the way of like a pipeline? So like a pattern I often see with like Jenkins is like you have your build and test job, and then you have like a deploy to staging job and like a deploy to production job. Like, does Drone have any kind of decent story around that, or is it just like you set up different jobs for different deployments to different environments?
So that's a very good question. So the question was, I'll fix the speakers in a minute.
Okay.
Does Drone have the idea of a pipeline? And I just looked at the Drone YAML file, which is continuously being developed on. I saw a pipeline keyword. But this is an argument we have. I use CI, the CI tool as a pipeline tool. And I'm going to say no, Drone does not have that right now. I think we prefer to specific tool like Spinnaker or Go. Do you have any feelings on that?
I think a lot of people implement their pipeline on top of the CI largely just because it's convenient, because you can kind of like chain jobs together, either via Jenkins or, I've seen people do it in Travis by basically like having one job commit to another job's Git repository and thereby triggering another build. I know Concourse CI is also like another, it's like CI, but also very pipeline driven. So I think it'll be interesting, to see how that all pans out. Like, do you keep the CI separate and then have something like Spinnaker, or do you have like a CI that's kind of married to the pipeline? Because they are really similar concerns.
It's very complex. I agree. It'll be, I think, pans out. I think we tried doing it with Travis and maybe Matt on your experience with Travis. Do you want to say anything? Or?
I'll try. There's a lot to summarize. I tried to prove of concept some pretty complex build deploy workflows from Travis CI, leveraging conventions like what Matt was describing. Build would trigger something, some subsequent step in like a to deploy through, continuously deploy through functional tests along the way, and GitHub pull requests being mechanism through which that was all orchestrated and required in our case, required that the Travis YAML file be ever evolving and part of the pull request depending on intent and a little cumbersome. I think you could probably imagine ways to engineer around that, but that's where it landed within our for proof of concepting.
Cool, thanks.
Cool, thanks. All right, so I'll close these tabs. Matt, did you boot me from screen sharing? Share?
I believe I can.
I believe I can.
I have my control room thing here, so I can even mute you and do all sorts of stuff.
All right. Let me know when you
Cool.
back back.
Yep, just about to here. Okay, and I might, this is kind of expected, but I might take my headphones out while I'm presenting. I get a feedback loop coming from like your speakers back through your microphone and then back here. So I think what I'll probably do is do a good chunk of the presentation with the headphones out. So ping me on Twitter if like someone's throwing their hand up and needs a question answered.
All right. Brian, you want to raise your hand? Can you see Brian's hand?
And not with the slides up.
Where's
That's the thing.
There we go.
Yeah, I get some of the audience, but I might have to play with like 2 monitors or something like that and experiment with this because I can sort of see the audience, but not particularly well. At least the echo stopped. That's interesting.
Okay. Well, I'll just interrupt you if something comes up.
Okay, cool. Yeah, and I'll keep my phone handy, so feel free to send me a message on Twitter if someone's trying to get a word in and I don't notice it. Cool. So we're back now. I can take this down. Yeah, there is definitely. I mean, we're going halfway around the planet, right? So there's going to be a little latency. And thanks everyone for bearing with me. Basically, I wanted to experiment a little bit with like how far I could push this remote thing and, you know, being involved in community events and things like that. So I pinged Jearvon and he was willing to bear with me and try to pull off this remote presentation thing. So I appreciate everyone in the room as well. I hope the quality is pretty good. We're getting a YouTube broadcast as well. You know, so if the quality on this doesn't come through too well, I'm hopeful that the quality on the YouTube recording will be pretty good if you want to go back and review. So let's get this thing started. So what do people think? Should I click it? Should I not click it? Does this make anyone nervous? Sitting in front of this terminate instances screen, you don't know what's going to happen, right? It's yeah, obviously it's a screenshot. You know, I didn't want to just throw clients real EC2 dashboards up on a screen, but yeah, this is like the first essence of chaos engineering, right? So just going in and basically terminating some things and asking yourself, you know, how will I feel about this? Like, does this make me nervous? Can I push this button safely? And will my stack handle it gracefully? And I find more often than not, the question, you know, people do have a lot of fear and reservation around putting this termination button. Hopefully by the end of this talk, you'll have some ideas of how to have a little bit less anxiety around terminating instances and torturing your stack. So chaos engineering for everyone else, kind of a little play on the Giphy thing. So we have CFI, I guess. And basically what I wanted to do is, you know, there's a lot of articles floating around about chaos engineering. It's a big topic. There's a lot that can be done. What I wanted to do is introduce everyone to the basics of chaos engineering and hopefully give you some ideas about how you can implement it even on a very small scale. You know, even if you just have a handful of nodes and you're just playing around with something, you know, you don't necessarily have to be Netflix to employ some of these strategies. So we're going to cover why chaos. So what, you know, why do we do these things? Why are we going to torture our stack in the first place? Types of chaos. So there's a couple of different types that I dealt with at Netflix that are pretty common. And, you know, if you read chaos articles, you'll probably see these different types. And then finally, creating chaos. This is where we get a little bit practical and I talk about approaches that you can take on your stack. And then I wanted to throw in a couple common concerns. Since I had a decent part in running a number of these exercises, there were at least like a couple of themes that came to mind as far as people's reservations go for running these chaos exercises. So wanted to make sure everyone there got a chance to hear those and hear some of the common ways that I would try to work with teams to alleviate these concerns. But first, so this is me. I don't have video up, so you can see my nice little portrait shot there. I am a freelance reliability engineer right now. So if you're interested in implementing these sort of things. Oh.
Pause.
Are we doing okay? Technical difficulties?
Well, the screen. Yeah, it was going so well. So one screen and
AirPlay problems, huh?
yeah.
Just watch the laptop.
What's that?
We just watched the laptop.
I'm nervous. Why are you making jokes?
Chaos. Okay. Do you have my nice pretty mug up there now?
Yay!
Yay. Okay. Okay.
Okay.
All set?
Are you guys okay with the TV?
Yeah.
Testing, testing.
Can you say something?
I sure can.
All right, good.
Okay.
Sure can.
Cool.
All right.
As I was saying,
Come on,
so,
AirPlay. All right, go ahead. Sorry. Are you there?
yes. Laggy, but
Go
I'm
ahead.
here. Okay, good. Everything working okay on that end? Okay.
Yeah.
All right. So as I was saying, so this is me. I'm at Matt Schaffer on Twitter. I'm a freelance reliability engineer. So if you're interested in this sort of thing and would like some help implementing it, let me know. I'm a longtime cloud automator. I was really hoping for a Mexican wrestler mask for the automator, but I could not find it. I don't know. Maybe there was no Leliche wrestler by that name. Anyway, I've been doing Chef and AWS especially for quite a number of years now. I don't know, I guess 5 or 6. So have some experience in these things. I worked at Netflix, etc. That's sort of the big claim to fame that I've been touting ever since I left. Unfortunately, I could not take my Netflix position with me when I relocated to Japan, but we'll see. I'm still working on them. I'm keeping in touch with them, and maybe we'll be able to break that seal and get some Netflix remote engineering going on. We'll see. But anyway, so while I was at Netflix, I spent a good chunk of time dealing with reliability engineering and also helping run these chaos exercises. So I think that put me in a decent place to be able to talk about these sort of things. So I had my own sort of personal sponsor I wanted to throw out here. So this is just a quick aside. I volunteer for a project called Safecast. Safecast is a community science project for monitoring radiation around the globe. It's an open source Rails application. So part of the reason I wanted to present here was not only to experiment with remote presenting, but also to help get the word out a little bit. If anyone there is interested in kind of coding for good and helping people understand radiation, and also we're getting into air pollution now and how it affects them around the world, check out github.com/safecast. The repo is up there. You can ping me directly and I can help get you on board as well. So we would love to see some more developer volunteers. We have a lot of hardware people, but not a whole lot of Rails people. So cool. So why chaos? So why do we do this? We do this because things break, right? You'll hear the usual list, right? Disks fail, CPUs go wonky. You could have bad memory. People trip over power cables. It doesn't really matter where you are. Things are going to break, and the more things you have, the more likely that things will break. And just to give you the cloud is better in some ways because you don't have to worry as much about your own hardware or the air conditioner is leaking or all the kinds of stuff that you have to deal with your own data center. The cloud has its own problems too. So in 2005, Cloud Harmony, they track the uptime of various cloud providers. And you had even Google. You would think Google knows a lot about high availability and uptime, but even they clocked in at 11 hours and 34 minutes of downtime in 2015. So AWS had a pretty good year, only 2 hours and 30 minutes, but things happen. There's a very long list of AWS outages, some of them very big and very long. These are just like a couple of dates that I pulled up. Maybe some of you in the room even remember some of these. When AWS goes down, so does a decent chunk of the web, especially when US East goes down, a decent chunk of the web does because so many people are just deployed in US East and outages there affect so many other sites. So, when would you rather these failures happen? Would you rather have them happen pretty much during the day when you have like an office full of people, working away and ready to respond to things, or would you rather them happen at 3:04 a.m., which I think is sort of I feel like the 3 a.m. to 4 a.m. window is like the hinterlands where it's like really late or really early and you don't know which. And for some reason, PagerDuty has a tendency to go off right in that window every single time. So I think most people would agree that you would rather have these failures happen, when people are ready to respond to them, and you can control them, and you can learn as much as you can because you're not just trying to stop the bleeding and go back to bed, which is what would happen if things broke at 3:04 in the morning. So that's the case for why chaos. Does anyone? I'll maybe throw out for quick questions. That's the basic idea. Things will fail. That's the question of when they fail, and would we rather let them happen or control when they fail? Everyone cool as far as that is concerned? Any hands on that, Jearvon?
No.
Cool. All right. Good. So next up, I wanted to talk about the different types of chaos. So the imagery here is courtesy of the Netflix Simian Army project. So this is an open source project that has a lot of the code that's used to do the various Netflix chaos exercises. So I'll talk about a couple of the different major types. There's obviously a lot of variations that people can do, but I think these are the big themes that when people talk about implementing chaos engineering, probably going to implement one of these. So first up is your chaos monkey, right? I think hopefully a good chunk of the room has heard about these. I'd asked people to throw up hands, but I can't see the hands anyway. Right, the chaos monkey is the little guy who runs around and does these small scale terminations, right? This most often takes the form of like an instance termination. It doesn't necessarily have to, but what it will do is basically shut down a chunk of your service regularly on some sort of an interval. Obviously, the Netflix chaos monkey is how that works. I've seen other variations on this, but the idea is to basically have your platform set up such that there will be some low running level of terminations continually at all times. And you want to run this with as little discretion as possible. Obviously, you want to be a little bit careful as far as, scale of instances. So if you only have if you're taking like a lot of traffic and you only have 3 instances serving your traffic and very little overhead, you might want to address that before you start, terminating one of those 3 instances and find yourself under provisioned for the load that you're handling. So you want to give yourself a little bit of overhead to handle these terminations, but ultimately they should be a no-op. So, and I can say from working at Netflix from experience, I ran a fairly wide variety of services from big to small, and in every case we were not worried about these chaos monkey terminations. We knew that every once in a while you would lose an instance and it was no big deal. This is getting into this frame of mind is good because no instance will be special. Everything will be assumed to get lost at some point, which is especially important when you're running on one of these cloud providers because more often than not, especially as you scale up, you will get notices of like terminations and reboots and things like that as hardware is scaled in and out of those data centers. And even if you do run your own data center, sometimes you'll lose a host. So rather than kind of waiting for that to happen again, like we said in the why stages, what we're going to do is control that and then also have it happen continuously and on any service. There was an opt-out flag, but it was also a very cautiously used opt-out flag. And we would, in reliability engineering, we would keep an eye on which apps had flipped the opt-out flag for Chaos Monkey and work with them pretty closely to make sure that they opted back in to Chaos Monkey terminations. Obviously, the data tier is the one that's going to be the hardest because there are fairly few databases that are going to be okay with just losing a node every once in a while. And that was also the one, even on Cassandra, which is probably one of the more fault-tolerant databases around. Netflix took some time to get to the point where they were confident running Chaos Monkey on Cassandra as well, but they did get there. But at least in your stateless tier, this should be a no-brainer. The only reason I could see to not terminate these things is that sort of being under-provisioned question, which hopefully your business is going well enough that you can afford that little bit of extra overhead and be ready for terminations. Cool. So that's Chaos Monkey. The next one up is our Chaos Gorilla. So this is larger scale terminations along your redundant axes. So in AWS, there's going to be availability zones. If you're running a different cloud provider, usually they have isolated data centers in a given region. Or if you're running your own hardware, you might be able to do this along rack boundaries. So instead of doing single instances, what you're going to do is terminate a large bulk of instances. This one you're going to want to run periodically rather than continually, because getting back to that sort of overhead question, if you terminate 1/3 of your capacity, you have to make sure that the other 2/3 are going to be ready to handle it, which can be a little bit of a hardware spend. So you might want to do this, for example, earlier in the day when traffic is going to be a little bit low, so that you can feel pretty confident you're not going to be under provisioned. Or the other thing to keep in mind is if you're auto scaled and you can get that extra capacity in your other 2 redundant zones, you want to make sure that you can scale up if you want to leave this thing running overnight, for example. So you want to run this one with a bit of care. The monkey runs continuously. The gorilla is something that you would actually pull people together for on a quarterly basis and let people know that this is going to happen and let people know when it's going to happen, and try to make sure that the teams are pretty ready for it, because you will see things that go a little bit pear-shaped when you do this. It's a pretty big migration to take out an entire availability zone. Probably going to be 1/3, or in some cases even half of your architecture. The next one is data center level evacuations. Run at Netflix, we tried to run these at least twice a year. When I was there, I can't speak to the frequency right now. Run with care, but one of the interesting things is that the data center level evacuations typically were a lot easier than just like the zone level evacuations, because mostly what you're just doing is shifting traffic between 2 regions on like a DNS level. So while it was something that you would still run with care, it was actually a little bit less risky in some ways, because you were just doing like the sort of DNS redirection that might happen if you switched, if you had people moving around or kind of like a DNS resolution problem that maybe geolocated someone to a different place. There's like a certain low level of misdirection between data centers just because of DNS anyway. All you're doing here is basically forcing all your traffic from one data center to the next. Obviously, you have to be running into data centers to begin with, which is something that not a lot of people are doing. So this is one that's going to be a little bit harder to reach, but definitely something to strive for as you start to go multi-region. Next one up is this is Latency Monkey. And the idea here is to make things slow. You do this one service at a time, typically. So what you'll do is have one backend service, call it your membership service or your user service. And what you would do is make all calls coming into that service run a little bit more slowly. And I run this very carefully, because actually so far of all the ones that we talked about, this is the one that's actually most likely to cause problems. Terminations are pretty easy in the grand scheme of things. Latency is a little bit trickier, because latency, it's hard to predict exactly how latency is going to impact a system. You could see thread pool exhaustion, you could see file handler exhaustion, you could see user behavior changes if you have a big enough set of users. If a certain feature is slower, then users might not use a certain part of your site. They might go somewhere else. Latency is kind of a tricky one. It's really hard to predict how adding latency is going to impact the system. So you would want to run this one carefully and also slowly. So you would inject a little bit of latency to start and then ramp it up little by little as you observe the effects of the latency. Cool. Those are kind of the big ones. And then there's a lot of other stuff that you can do too. You can shrink the size of any like thread pools or connection pools that you might have. Launching on undersized hardware is kind of a fun one. You might run, M3 extra large most of the time. See what happens if you run an M3 large. Like, will the thing even boot, or does it manage to handle just with like higher CPU loads and stuff like that? This is a good one to test. Restoring from backups is one that it seems so simple, yet so few people do it. This is like not entirely chaos engineering, but more just kind of being ready for disaster recovery. If you have backups of some sort of system, make it a point on like at least a quarterly basis, I would say, to try restoring from those backups and make sure that you know what that procedure looks like. Because otherwise, it's very easy to run into a situation where you know, something went wrong and maybe, you know, a bunch of data tier instances got terminated and you have to restore from backups, and no one on staff has actually done that, you know, in the last year or so. So being ready and knowing what the procedure looks like is important. This is one that actually doesn't have to happen on a production path, which is nice. You know, you could, especially on AWS, you could spin up new hardware, and you just want to make sure you know what that procedure looks like. Triggering kernel panics is one that we've played with at Netflix as well. It's not that different from a termination, really, but you know, it's fun. People like to do low level stuff, and use your imagination. There's lots of interesting ways that you can torture your instances as well. And I'll get into some of the specific things that you can do. But you know, I think there's lots of other even very application specific sort of things. You know, if you had like a very location specific application, you know, see what happens if you offset all the GPS coordinates by a certain amount. You know, you can have some fun with this and see what happens. Cool. Any questions on types of chaos? Are we good? How's everyone doing? Is the connection holding up? See if I can see everyone's faces.
Pulling up. You're going out so often. You're testing out the latency a little bit.
Yeah, a little bit of latency monkey here. Cool. You turned off video on your end, I guess. Okay, cool. I can go back. Just curious to see how people are doing.
Yeah.
Cool.
Yeah, we turned the video off too, Tom. That was why you can't
Oh.
see it.
Okay.
Gotcha. Yeah, that makes sense. Try to conserve bandwidth. Cool. So now I'm going to get a little bit more practical. Want to talk about creating chaos. So there's lots of ways to do this. They're obviously going to depend a little bit on how your stack runs. Some of them are very simple. Some of them are more complicated. So the first thing, though, before we get into actually you know, running these things and kind of torturing our instances, is preparation. So the first thing that you're going to want is the ability to measure. You know, so here's just like a graphite dashboard. One of the first principles of implementing chaos in general is you want to have a bit of a hypothesis going into what you're about to do, and then you want to be able to you know, it's scientific method. You want to have your hypothesis going into the experiment. You want to run the experiment, and then you want to be able to qualify the results of the experiment against your hypothesis. And so having some sort of measurement capability is going to be really critical here. This could be graphite, it could be CloudWatch. You know, if the system is small enough, you could probably even get by with logs and lots of like grep and things. But you don't want to be blind to your infrastructure before you start running these things. You want to have a sense for whether or not your hardware is running well. You know, keep an eye on things like CPU and load. And one of the things that I think is probably even more important than that is try to get a sense for what the key performance indicators of your business are, and keep an eye on those. So at Netflix, the one that we chose was video starts per second. So you know, how many people actually clicked the play button in a given second, and that was a pretty good indicator, because if everything was pretty much working as expected, then people would be able to click the play button and they would watch some video at a reasonably regular rate. And so you could watch for deviations in that, you know, people clicking start, and that would tell you, you know, things are not working correctly. So you'd either see a big dip, which means people aren't able to even like get to the play button and click it, or sometimes you'd even see like a big spike, which would indicate like something else is going weird and people are getting like kicked out midstream and then having to play again. So, you know, having some sort of predictable metric of how people use your application and being able to watch for deviations in that is really important too. Because even if, you know, you might not see you know, this particular chaos gorilla exercise might be causing load on a deeper down service, which is actually under provisioned, so that we can't just terminate a third of the instances. You might not see that right away, but you should be able to see pretty quickly that like, hey, people aren't hitting the start button. So like, you know, something's up, and people aren't doing with your app what they're supposed to be doing with your app. And that gives you a place to go look deeper. A lot of what's going to happen during these exercises is you're going to find places where your monitoring insight wasn't good in a particular area of the system. So having those kind of key performance indicators for your business monitored and having a sense for, you know, what the pattern of those on a day-to-day basis is going to be pretty important to knowing what kind of an impact you're having with these exercises. And I could do a whole talk on that. There's tons of ways to measure. I love a good time series line. But having something in place, if it's a relatively small app, New Relic can be good for this too. You can basically watch your error rates in New Relic, and I've seen a lot of people run that way, and that's not bad. It'll do the job. I like monitoring the success indicators as well as the errors, but if nothing else, at least the error rates can help. You're going to want to automate your provisioning in some way. It's kind of up to you how you do this, but we're talking about terminating instances. We're talking about kind of torturing the system to where instances might fall over on their own. So you want to have something in place to put those things back. You don't want to have an infrastructure where you're provisioning every single instance one-off, because you're going to create a lot of work for yourself in that case, trying to bring these instances back online, when what you really should be doing is being able to analyze the results and getting a deeper idea of what's going on. This is another thing that could be a whole talk on its own. CloudFormation is an option. I've used Sparkle Formation and Schaffer on top of CloudFormation. There's also Troposphere, which kind of makes working with CloudFormation a little bit better. Doing some work with Terraform lately. It's kind of up to you which tool you choose. And I put a little auto-scaling group mark on CloudFormation. You'd want to do this in Terraform too, but another thing before you kind of embark on these termination exercises is to get as much as you can into auto-scaling groups, especially even if it's like a one instance service. An auto-scaling group set to 1 is going to force you to think about some things about how that instance comes online before you even embark on these exercises. So if you're not already launching your instances into auto-scaling groups, that would be a great first step, because even before you start torturing the stack, it makes you think about, when something is in an auto-scaling group, you don't have the option to like SSH into the machine and tweak it. That instance has to be able to come up on its own using only user data and then whatever it has access to, like either S3 or whatever. So it forces you to think like, okay, in a hands-off scenario, how does this service bring itself back online? And that's going to be really important, because when you start doing these termination exercises, if you don't have that, then there'll be no, you can terminate an instance and maybe things will be okay, but you won't be able to get back to steady state without manual intervention and bringing these instances back online, which is going to be a lot less fun. So. And most of the cloud providers out there have some sort of way to do this. I think if you really needed to implement your own sort of instance recovery procedure in a data center, you could do that as well. But ideally, you want as much automation around your provisioning process as possible, so that these things can kind of pop back into life once the test is over. Another thing I'll throw out there is packaging. So especially if you're doing instance terminations, if you're running in an auto-scaling group, if your provisioning process involves checking out code from GitHub and like running bundler and doing a bunch of things like that, your recovery process is going to be a lot slower. So as much as you can, get things into like either debs or RPMs or Docker containers, or use something like Packer to build an AMI. This is not a hard requirement, I would say, for doing chaos. But if you're terminating an instance and then the instance comes back, and the first thing the instance has to do is spend 20 minutes in chef land, like checking out stuff from GitHub and like running bundler and trying to deal with Ruby gems, like probably even those first couple terminations, you're going to have some pain, because maybe Ruby gems had a little bit of a glitch right in the middle of the termination or something like that. So you want to make sure these things are kind of ready to come back on their own, and they come pre-packaged with as much as you can possibly kind of get in there. Obviously, when an instance comes online, there's still going to be a little bit of a configuration step that needs to happen. You can use Chef for that. You can use kind of whatever configuration management tool that you like, but try to avoid the case where instances are coming up from just like a base Ubuntu installation and then installing everything on top of that, and especially like if they're compiling things on top of that. Almost every single one of these like chaos tests is going to have some sort of failure if that's the way your provisioning is working right now. And so while you can run Chaos Monkey and things like that, you might not be too satisfied with the results, because they're probably just going to tell you that you need to prepackage more of your your provisioning process. Another thing is to be ready. So have a process, because a lot of these chaos exercises will cause some fallout, right? That's kind of the idea. So and you can explain this to your management as well. Like it's not, we're not running this thing and expecting it to be totally clean. We're running this thing and expecting to have some impact, but be able to control that impact. So you are torching your stack. You are potentially causing some errors for customers. But the win, remember from when we talked about why chaos, the win is that you're doing this during the day when you can address it in a matter of minutes, as opposed to 3 a.m. where it could take you, it could take you on the order of hours to like kind of wake everyone up and orient yourself and get the thing fixed. So you're trading a small known impact, a small and controlled impact, I should say, not known necessarily. You're trading a small controlled impact for a potentially large and uncontrolled impact if you let these problems come up on their own. So have a process for how you're going to handle that, right? Either something like PagerDuty or VictorOps. You want to be able to get in touch with people. You might schedule like a war room or like a hangout or something like that to run these things in. So that way people, if they see problems that they think might be related to the test that's going on, they can come talk to people who are running the test. We would often have like a chaos engineering chat channel while we were running these things as well, so that way people could like pop their heads in and say like, hey, I'm noticing something weird over here. Like, is it because we're in the middle of like a guerrilla exercise, or is it just something else? And have a kind of a process for how you're going to gather this data going into the exercise, right? And I mentioned Twilio here just because like being able to get in touch with people, conference bridges, voice communication, these things are good for these exercises as well. Have a process for when things break, what do we do? Doesn't have to be big. If you don't have one today, what it can really come down to is just like a Google form where you essentially have a description of what was observed and a place to put comments and a place to put like a timeline about it. It could be, we've used shared Google Docs for this in the past. At Netflix, Jira was sort of the place where we tended to record all this information, but one time Jira was also impacted by an outage. And so, yeah, just load up Google Docs and load up a Google Hangout and go from there. But know the information you're going to be looking to collect before you go into the exercise. And then finally, we're ready to break things. And this can be really simple, right? This can be kill-9 HA proxy on one of your load balancer instances or whatever, right? Or I guess it'd be a PID. I should be kill all. But anyway, as you can tell, I didn't actually hit enter on that command. I just sort of typed it out to give you an idea. This can be really small, and that's okay, right? We're talking about just getting started. We're not talking about necessarily like Netflix scale chaos engineering. What we're talking about is on the small, being ready and having a sense for what's going to happen when you just kill things. So this can really take the shape of like, hey, everybody, at 9 o'clock tomorrow, I'm going to stop HA proxy on one of our front end load balancers. I expect that we should be able to weather that, but we'll see. And we'll be collecting information and all that kind of stuff. So this can be a good way to start, essentially, just by stopping services and starting services. This is also nice because if you're not ready for like full-on terminations yet, this will preserve your instance, and it's also usually pretty quick to undo, right? If you just stop a service, it's usually pretty easy to start it back up again. And then also, if you're talking about EC2, terminating your instance, you're going to lose any sort of ephemeral storage. You're going to lose the IP address, whereas just stopping and starting a service is not going to have that impact. So you can even basically, this can be your tiny little chaos monkey, where just start by going in and taking services that you feel should be redundant, but maybe you're not sure, and come in and terminate them, say on a once a week, Monday morning, take out your aggressions on a couple of services or something. Kind of up to you how you implement this, but it doesn't have to be big, right? Simple shell scripts will do the job. In fact, a number of the more interesting things in the Simian Army database are not big Java apps, but actually just like these little shell scripts that go in and torture instances in various ways. So yeah, there's the Simian Army. We talked a little bit about these guys. We have the Chaos Monkey that's going to be terminating your instances, the Gorilla, which is going to be terminating everything in an availability zone, Kong, which is moving traffic back and forth, Latency Monkey, which is essentially if I was in the audience, or if I was there, I'd probably ask for like audience. But what's a good way to simulate latency in a service? It's actually as simple as adding a sleep, right? So in your application, what you can do in order to generate latency is to go into a particular part of your, a key process in your app and just run it with an if statement around it. You want to be able to have a way to turn it on and off, but essentially just insert a sleep statement. So the way that we would typically run a latency monkey at Netflix when I was running them was we had our RPC client library that built into it had a switch that when you turned it on, it would basically inject a certain amount of sleep before every request. And this actually brings me to one other point, which is that however you decide to implement your chaos, it's going to be important to know how to turn it off. And ideally to have turning it off be something that can happen pretty quickly, right? So like if you're injecting latency, you want to be able to do that with some sort of environment flag. Maybe it's like a bit flag in Redis. How you implement the flags is up to you. But make sure that ahead of time, here's how we're going to be injecting the latency or the dropped packets, or here's how we're going to be performing the termination. How do we expect to get back to steady state? And make sure to exercise these once in like a test environment before you go into the production environment, so that you know how you're going to be turning this experiment on and off. And ideally, it shouldn't require like a full redeploy. So I wouldn't advise, say, dropping a sleep in your code and deploying the whole thing, and then the way that you turn it off is to like take the sleep out and like redeploy the whole thing. Like that's probably not going to be a very effective way to try this, because especially if you're running like a full deploy to turn these things on and off, it's a lot of extra variables that could be coming along for the ride, which you don't. When you're analyzing your data, you don't want to be second guessing yourself, saying like, okay, we injected this much latency, we ran a deploy to turn off the latency, but now the latency isn't the same as it was before. Is that because it's some sort of residual fallout from the experiment, or did we introduce some other like chunk of code or something when we were going back? So you want to make sure you have some sort of way to signal your application at runtime, hopefully without any sort of restarts, to say like, hey, that latency that you're doing, take that off. So with the case of like starting and stopping services, obviously that's pretty straightforward, but depending on the type of torturing you're gonna, do for your instances, it could change a little bit. There's a couple other monkeys in here that I'm not too worried about. We have conformity monkey and security monkey. I feel like these don't fall into the chaos program as much, so I'm focusing on the chaos monkeys here, but they do make for a nice little trio. So cool. And there's a couple of tools I wanted to throw out there for implementing these things. So this particular page on the Simian Army wiki goes through some of the more creative kind of torturing approaches that Netflix has come up with. Some of them get run regularly, some of them don't. There's also just a handful of these little shell scripts that mostly just use the TC command to do things like introduce like OS level latency and things like that. And these are good ways to go to, because they don't require any sort of switching inside of your application. And it doesn't, Netflix had the benefit of being a mostly Java stack and having a lot of like shared libraries on that Java stack. So we could implement a certain amount of chaos just like in the JVM without having to reach out to OS. But the OS, Linux operating system, it has tools built in that can tell you things to like drop packets and things. There's also a nice little tool called Comcast, which wraps up a number of these things. Kind of a funny name, given that we're in Philly.rb, and I know there's probably some Comcast people there, but I guess this guy didn't like his home connection too much, so he decided to term his latency and failure injection in the library after his ISP. This is another one that implements those sort of like IP tables or traffic control style like latency injection, or you can also, for example, like you can tell IP tables to drop a certain percentage of packets. These are kind of other ways that you can torture. And then finally, there's also a tool that I found not too long ago called Muxy, which is a proxy that lets you inject these sort of things. The only thing is I don't believe this one gives you any sort of like really good runtime control. Like you have to restart the proxy to change the settings. But if you're doing kind of chaos testing this small and you just kind of want to see in a test environment how things react, something like a proxy could be a good way to handle that. And then the final bullet is just app level. So like I talked about, you can drop a sleep inside of your application. You can put kind of any sort of if statements or exceptions or things like that inside of your app that you want as well. And then a lot of the Netflix, especially like the latency injection exercises or the failure injection exercises, they all happened at the Java level, where so you had flags in the application that when set would cause a portion of the code to act suboptimally, whether that be injecting latency or injecting loss or doing extraneous retries or something like that. These are good ways to do it as well. So it doesn't have to be anything like big and fancy. You don't have to worry about running the big, Chaos Monkey itself and Latency Monkey itself are these kind of like big Java applications that could be kind of a pain to deal with. You don't have to get into that, so long as you have some sort of basic feature flag system set up. Could even be Redis bit flags, could be columns in your database, or however you want to do it. It could be as simple as having an if statement in your code that says if inject latency, then sleep 0.2 or whatever, and kind of going from there. But you do want to make sure that you have switches around them, so that you're not going to be doing a full scale redeploy just to turn off the experiment. And then finally, and I talked a little bit about, this is scientific method. After we inject some sort of chaos and see how things go and decide, okay, we've pushed this thing far enough, let's turn it back off. What we can do is sit down and examine the results. And what you're going to want to do here, I talked a little bit about timelines and kind of like having a process. You want to build a timeline of what happened when in the experiment, because obviously the temporal, the system is working together in real time. And so kind of correlating all of your anomalies in time is going to give you an idea of what caused what. So obviously the more granular you can have your metrics, the better. Also make sure that you're ready to kind of examine logs and things like that. If you're running very aggressive log rotation, you want to make sure to capture those logs from the test before they necessarily get rolled off or archived or whatever. Compare the results to your expectations, and then finally file tickets to remediate any bugs that are uncovered, or however you coordinate work in your team. And how certainly at Netflix, how quickly these bugs were worked was a decision of the team. So each team would make a call to say how how much they wanted to dedicate time to making sure that the next run was cleaner, based off of all the other stuff they had in their backlog as well. Obviously, there's a little bit of a human element here. There's ways that you can kind of help balance these things. I don't know if anyone's read the Google SRE book, but they talk a little bit about error budgets, for example. These are that's probably one of my favorite ways to try to temper feature work versus kind of these sort of more operational kind of reliability hardening tickets, is to basically keep an eye on your normal running error rates, and when they get above a certain point that the team decides on ahead of time, that's sort of your flag to say like, okay, let's pull back on the features a little bit and let's actually try to harden. And then obviously, before you want to keep an eye on those tickets so that when it comes time for the next test, you've closed as many of them as you can, or the ones that haven't closed, to watch out for them and see if they pop up again. Cool. And that's the basics for implementing, your own, albeit small or large, or however you want to make it, chaos program. So I want to talk a little bit about common concerns. I tried to brainstorm a little bit, but I feel like they really fell down into two categories. The first one is fear. So you get a lot of people saying, my service isn't ready. I don't know if it'll come back. We're running really hot right now, and we have some sort of like a garbage collection problem, and we just know that this termination is going to totally knock us over. Having that fear of like the unknown of what's going to happen in these exercises is a very real thing, and a lot of teams definitely express it. I think the main ways that we would try to work with the different development teams to try to stem this fear is that the 3 or 4 a.m. right? When would you rather have this happen, right? Like if you're under provisioned and you have GC problems, this thing will falter at some point. Would you rather have us wake you up in the middle of the night because it broke and now we have to try to stop the bleeding? Or would you rather us do it at like 9:30, 10 o'clock in the morning when you've had your coffee and you're ready to go? And we can respond to this thing, and we know ahead of time how we're gonna like turn it off and get ourselves back out of the nasty situation. And by and large, people will agree that like, okay, yeah, you're right. You know, or like if anything, maybe let's like do it next week. We'll risk the 3 or 4 a.m. for 1 more week, and then we can run it. But it's usually a pretty good one to sell people on the concept. Another one, a coworker of mine on the Netflix reliability team, who he's off doing his own thing now too, Rude said to me, keep doing the scary thing until it's not scary anymore. And I think this is almost like an adage for life. You know, if you feel nervous about anything, you know, be it public speaking, be it chaos engineering, whatever, one of the best ways to make a scary thing not scary is to do it a lot. The more you do it, the less scary it's going to become, and the easier it'll be to just go ahead and do it. And every time you do it, you're going to learn more about it. You're going to learn that like, hey, maybe this idea of terminating instance is not as scary as I thought it was going to be. You know, kind of getting over that initial hump and that initial fear is the important part. And then once you kind of get these things rolling, they tend to get a lot easier. So, and it was certainly true. Like the first time we ran Chaos Kong, it was like this very big, like, oh my God, what's going to happen kind of thing. But eventually by, you know, the 4th or the 5th time, it was, not to say it wasn't scary at all, but it was certainly a lot less scary because we knew going into it, what we were going to have to do to get back out of it. We knew going into it that we'd addressed a large number of problems from the initial run. And you know, eventually, I think it was probably by the 3rd time or so, Wang had a picture in a number of his presentations where he had this like perfect flow of traffic where you see it go from one data center to the other, and the you know, the global keep metric just doesn't falter at all, right? So the more you can do it, the more practice you're going to get, and the easier it's going to get in the long term. Getting over that initial hump, having a champion to push it forward is the key part there. And the next one is priority. So we already have too much on our schedule. We need to launch X, Y, and Z this week. And this is a place where, like I said, the error budgets can come in handy. The error budgets can come in handy for kind of, if we can agree on availability ahead of time. When we get under that availability, this is sort of a time when we need to focus on these reliability tasks and running. If we don't know where we need to tune, running one of these experiments is a good way to pull action items out of your system, right? So if you're just having outages every once in a while that are kind of, you don't really know what's going on, running one of these controlled experiments can be a really good way to see, you know, what is going wrong, more specifically, kind of like under a microscope. The one of the ones I'll use here, obviously, and I think this goes true for a lot of software projects, is one of the best ways to address priority is to put a dollar figure on it. And so to ask, you know, whoever is deciding priority, be it manager, be it director, whatever, how much would it cost our business if we were offline for 12 hours? Because ultimately, if you're not running any sort of chaos program, this is probably what you're signing up for. There's a good chance that it's somewhere down the road, you know, some database is going to run out of capacity, some key service is going to run out of capacity, something's going to go wonky and totally flood the service, and you're going to be down. Probably, you know, it could easily be for 12 hours. You know, maybe it'll be 3, maybe you'll get lucky and it'll be 3, maybe it'll be 4. But there's like a really good chance this would be 12 hours. And ask yourself, ask your directors, ask the people who run the business, what would this cost? And for some cases, the answer might be not much. And in which case, maybe you don't have to worry too much about running a whole lot of chaos exercises. But I think most kind of operating businesses would say that, you know, could tell you very specifically, like being down for 12 hours would cost us this many signups, for example, which can translate to dollars really quickly. And then you can basically use that to prioritize and say, you know, do we like look at the potential lost revenue from this 12-hour outage versus what we have on the roadmap and the potential gains in revenue, and base priority on that. And then I had one more. I didn't have a good slide for this. I had one more sort of priority idea that came from my old boss, Bruce. He had a fun way that he proposed. I don't know if he ended up implementing this, but his plan was actually to, when there was like a key performance indicator failure, is to actually page every engineer in the company unless their service was already proven resilient in one of these chaos exercises. So the idea being the incentive would be, if you hadn't run like a latency monkey on your service in the last 6 months, you would automatically get put back onto the page everyone schedule. So that when there was an outage, you would be woken up at 3 a.m. I don't know if he implemented that or not, but I thought that was kind of a fun one. I wanted to throw that out there. Maybe someone else will try that. It's a little bit aggressive, but it could set up the priorities in a nice way. Cool. And those are the two common concerns that I felt like really came up. They were all around fear or priority, and those are the ways that I tended to work with teams to try to get them over those humps. So just to finish up, to recap, failure happens. It's going to happen, and the bigger you get, the more likely it is to happen, and also the more expensive it's going to be. Failure is easier with experience. So if you've run these things, if you've done it before, if you've had previous failures before, every time you're going to be learning more about your system. You're going to be learning more about your business. You're going to be learning about how your users react. The more you can do to experience these sort of outages, the better off you're going to be. These experiences can be created, and that's what we're talking about with chaos engineering, is to say that, we don't have to wait for these things to happen. What we can do is actually create them on a smaller scale at a time that we can control them. Start small and measure carefully. So that's part of the reason I threw that, kill-9 up there. You don't have to run big fancy Java apps. It can really start as simple as like, before you roll this service out to production, like run it in a test mode and kill one of the instances and see what happens. Production traffic is obviously ideal, but you don't necessarily have to start there. You can start with test traffic. You can start with JMeter, see how the traffic reacts under certain conditions that you're interested in testing in production. And then finally, practice this regularly. So once you have terminations running, set up a cron job that does it on a regular basis. Once you have a story around latency, make sure that every service has a little bit of latency injected to it, say on a quarterly basis. The more you practice these things, the less scary they're going to be, and the more reliability and sort of operational muscle you're going to develop around handling these outages, to the point where, Netflix obviously is like the big example of these, but they had the big AWS reboot where even Cassandra didn't notice. So because these things are being practiced so regularly, Amazon, they needed to reboot their whole fleet, essentially to address a security vulnerability. And even the stateful services at Netflix basically didn't notice. They had to replenish a couple of nodes, but the service itself stood standing, and there was essentially no fallout from that. I wanted to throw a couple of special thanks. One is to Bruce Wong. He did a lot of presentations on like the case for chaos and implementing chaos programs. He was my previous boss at Netflix. He's at Twilio these days. He's got a good sense for how to work with people and how to kind of push these programs forward, and did a lot of nice work with the chaos engineering team while he was at Netflix and while I was working for him. The Netflix chaos engineering team. So even, I don't know if anyone remembers Casey Rosenthal. He's a previous Philly guy, but he's got his hands in this. They recently had an IEEE magazine published that talks about a lot of these same concepts. Really good team there. If you're interested in this sort of stuff, I'm sure they would be happy to talk to you. I mean, what team isn't always hiring? But yeah, really fantastic group. I wish I could still work with them, but and maybe I will again at some point. But in the meantime, I had to move out of country, so here I am. And then they also set up the principles of chaos.org, which is a little bit of like a manifesto, which touches on some of these same topics that I talked about. Obviously, coming from the Netflix perspective, it's very big. What I tried to do here was make things a little bit smaller, and hopefully a little bit more approachable than what you'll see on Principles of Chaos or in IEEE. And that's it. I want to open up for questions. Does anyone have anything they've been rolling around their head? I'll switch back over to video here so that you can see my smiling face. Any thoughts about how to implement one of these things? Or has anyone maybe run one of these programs on their infrastructure and had any tales to talk about? Feel free to call BS on someone I'm talking about here too. I mean, I'm sure in different environments, this is going to be a lot easier or harder to implement.
I have an addition for your toolbox. So maybe a replacement for Moxie.
Mm-hmm.
Moxie proxy. You play with it. What do you think of it?
Yeah. So for Moxie, it's an injection proxy. The thing that I would hesitate as far as rolling out a production chaos experiment with this is just that as far as I know, it requires like a reload of the proxy to get back to a steady state, which might not be good, right? Because you want to be able to get back to a steady state as quickly as possible, and reloading a proxy that's between you and the service that you're calling could potentially have other impacts rather than just the latency that you're trying to inject. Anything that needs to get restarted or reprovisioned or something like that to get out of a test is going to be a new thing to introduce variables. So, but as far as like in testing, if you just need to, add an extra 5 seconds to one service, it's a really handy way to do that. If you're running in production, I would probably go towards more of like the TC or IP tables approach, because you probably have one service per instance anyway. But if you're testing, you might have a couple of services on an instance, or you might be running locally. You don't necessarily want to drop, a tenth of the packets from everything coming out of your laptop. You just want to do it on this one connection path, and Moxie is a really handy place to do that. Cool. Anybody else? Has anyone tried this? Has anyone has maybe like a quick show of hands? Has anyone terminated an instance just for the fun of it in the past couple of months? Anybody? Okay, by accident we got a couple of hands there. How did it go? Did it fall over? Did the thing totally fall? No? It worked? Good. See? It's not so scary. Cool. All right.
I guess I will try to ask another question. There seems to be two schools of thought. One is injecting chaos in the worst case world, like front. Like, do you have any arguments against one or the other? Or
well, the second was what, like defensive programming? You broke up just a little bit there, so.
Yeah, like just do a bunch of defensive programming up front, being careless and doing chaos in here.
That's a good question. I think they both complement each other. The one thing that I would say is, at least personally, I would tend to not try to code as defensively, because I would worry about hitting like a "you're not going to need it" situation, right? Whereas trying to be as ready as you feel like you need to be, and then actually running some of these exercises will help weed out where the actual failures are going to get produced, as opposed to where you think they might be produced. I think it's true in performance profiling as well. Like, you get some people that are like, oh, but this way is going to be faster. But then you actually profile the thing and you find out this thing that you hyper optimized only really gets called 3 times anyway. So what's the big deal, right? So yeah, I think they both run hand in hand. I think you're going to run some of these experiments and then have places where like you realize, okay, this should have been way more resilient. Let's fix that. The one thing I will throw out there is that a very simple thing that you can do at a time that I think is worthwhile is retries with exponential backoff. And a lot of people don't implement this, but and just to explain it for a second, right? So what you want to do is anytime you're calling an external service, you probably want to be able to retry that if there's some sort of a connection failure. And you don't want to just retry in a tight loop. What you want to do is retry successively slower, and then actually exponentially slower. So you might retry in a half a second the first time, 1 second the next time, and 3 seconds the next time, so on and so forth. There's a good Ruby gem called Retryable that implements this procedure. And so that's the one thing I would say is worthwhile to look at ahead of time, is making sure that you have decent retry loops around the places where your application is calling out to external services, because that's just going to benefit you kind of in general, because you never know when the network is going to falter or when like a service is going to be offline. That's having retries with backoffs and timeouts are probably like the one aspect of defensive coding that I think is going to benefit you even before you run some of these exercises. But I wouldn't get too crazy with, all sorts of excessive error handling and things like that. Let those fall out during the test. But, shit.
Why does Netflix go down?
Why does
In your
Netflix go down?
experience, what has Netflix gone down?
By and large, Netflix would have some sort of an issue, and down is relative, right? Down is like, is it Netflix totally down? Is it down in a region? Whatever. But I'll generalize and just say Netflix had some sort of an incident. Why it goes down is by and large some sort of human intervention. I don't have a hard percentile, but handling. I was on like the crisis response team for a long time, so I had got my hands in pretty much every incident that we had at Netflix, and almost all the time, I would probably say like 90% of the time, it was, I was making this change and I didn't expect an impact, but lo and behold, there was an impact on something. So, for the most part, it would come down to kind of like latent bugs in the software. One of my favorites was it was someone decided to use a Git SHA as a property. So it was basically like which UI asset to load, I think. And the Git SHA came out as 7E2835. And something in the property handler interpreted that as scientific notation rather than a Git SHA, and tried to turn it into like 7 times 10 to the 2485th power. And yeah, that was fun. That actually took out an entire environment. So, yeah, by and large, it's people making changes and having, not necessarily expecting the outcome that they were going to get. That being said, when it comes to chaos engineering, the larger, longer, nastier outages tended to be like service provider, like either AWS or like DNS level service provider problems. Those are the ones that were really ugly, and those are the things that with chaos engineering we were trying to stem. The single incidents that stem from someone changing something usually were pretty short lived, because typically before anyone would change something, they would file like a change ticket, and then on that ticket they would usually put kind of like what the undo plan is. So if this doesn't work, here's how we're going to get it back. And so you get a lot of these little short impacts, but not the really big ones were usually zone problems or ELB problems or regional problems, which having the chaos program helped a lot in getting around, or like the big AWS reboot, those sort of things. Thankfully, I think because we do so much in the chaos engineering space, like the reboot didn't really impact the Netflix architecture that much, and able to weather those storms, the cloud storms. Is that a good answer? Does that work for you? Any follow-up questions from that?
You need a human engineering, chaos engineering element.
I missed that. Chaos engineering friend. Yeah. Cool.
No, he wants a human chaos monkey, or chaos monkey human.
Yeah.
Human.
Wait, are you a chaos monkey human? Yeah.
I could be at times.
Okay, good.
If people want to reach out to me for questions or anything,
yeah, Twitter is good, or matt@schaffer.me is my email address, mattschaffer.com. Like I threw it, I'll throw the slides in the channel, but here, let me share my screen one more time. That right there is my Twitter handle, and so long as you get that spelled right, that's pretty much where I am everywhere. So.
Cool. Show us your neighborhood, or
Do I what in my neighborhood?
Can you show us your neighborhood?
Oh, I don't have a great view from my window here, but hold on 1 second. Oh, yeah, it's very rainy today. Let me get.
So all that is that we usually go to the bar after hang out, talk some more. We're probably gonna go to Furries, which is on June 12th, 12 to 13.
be really fun is if I could take you to the shrine that's not too far from here.
Well, you can tweet us a picture later. Sweet.
Japan. It's a lot like anywhere else when you're right in the neighborhood.
All right, Matt. Thank you so much. All right. See you later.
All right. I'll stop the broadcast. See you on Twitter.
Thanks.